Hi and welcome to this learning of MySQL HeatWave. And today, this is a part of a longer series where we're kind of doing introduction stuff of how to connect to MySQL database servers or MySQL HeatWave, as it's called now, and also how to connect from different sources, how to set up OpenVPN and stuff like that. That was covered in the last session by Stuart David. So this is a series where we're kind of building on the information from the previous webcast. So it's important, if you want to keep up to date, that there will always be recordings available from the previous sessions. So if you're having questions around how to connect to a MySQL HeatWave database, that was covered in the previous session. So I will refer to that. And of course, you can view the recording. So this is based on that you already have that knowledge. So today we will look at how to set up replication with inside OCI. So replicating in between two different MySQL HeatWave instances. So my name is Ted Wellmark. I will be delivering this session today. I'm a solution architect with Inside Oracle. I have some content on GitHub if you're interested in more hands-on workshops. And if you want to stay in touch with us, you can connect with me on LinkedIn, or feel free to join our MySQL community on Slack. You will be getting the slides and the recording of this, so you will have these links if you would like to join our Slack or connect with me later on. So before we start looking into how to do this setup on OCI, I wanted to cover some basics of replication because some of you might not be aware of when to use or how MySQL replication works, or what is MySQL replication. So I will give you a quick introduction into replication because we will use this to replicate data in between two different MySQL databases. So replication, simplified, it's the process of generating and reproducing multiple copies of data to one or more sites. So as you can see in the picture, you have your application. It's working with your production database. It's called server A in this picture. Let's say you want to have a replica, and the replica can be used for many purposes. In many cases, it's for disaster recovery or high availability. So you want to have a replica in case of your primary database server A fails. So you will then set up a replica server, and all of the changes that you're doing on server A will be then reproduced on server B automatically for you. So this is a continuous process of applying changes in between two databases. So let's look at some use cases for replication. So we will use it today for kind of disaster recovery, but it can be used for many other things. So disaster recovery is one thing. Migration to clouds, for example, with a minimal downtime. So you're setting up a replica server in cloud from your on-premise database. And then when you feel comfortable to migrate to cloud, you already have your data and your database residing in cloud, for example. You can also do upgrades. If you want to do upgrades from, let's say, MySQL version 5.7 to MySQL version 8.0, you can also use replication for doing upgrades with really low downtime. You can also use replication for scaling out read operations. So if you want to have more read capacity, or if you have some back office programs for reading data, you can scale out read operations. I will cover this in a bit more details in the upcoming slides. I'm also here, you have a reference to our manuals to read more about how to set up replication. So one thing is, and this is what we will use it for today, it's having disaster recovery, replicating in between two different virtual cloud networks. But you can also use it for having, let's say you want to have a replica, a copy of your database in cloud. So you have your primary database sitting on premise, but you would like to have, for redundancy, a copy of that database with inside a cloud vendor. Then you can set up inbound replication to our MySQL HeatWave database from your on-premise database for disaster recovery. Another use case, and this is the same picture, believe it or not, but this is for migrating to Oracle Cloud. So if you're not considering this only disaster recovery, but you actually are looking into migrate your application and your database to Oracle Cloud, then you can leverage replication again. So then you can actually migrate from on-premise to cloud with really a low amount of downtime. The only time you need is when you're actually stopping your application on-premise to start up your application in cloud, because your data will already be residing there. And with replication, you know that data is always replicated from your on-prem to your cloud setup. Another way of using replication is if you want to do a MySQL upgrade. So let's say you're having MySQL 8.28 here, and you want to upgrade to MySQL 8.29 with zero downtime. Or perhaps you just want to try out 8.29 to see if everything works. Then you can replicate in between different MySQL versions. So you don't have to have exactly the same version when you're setting up replication. You can even replicate in between MySQL 5.7 to MySQL 8.0. So if you want to do an upgrade from 5.7 to 8.0 and your primary database is 5.7, you can replicate to 8.0 instance, and then you can do some small read-only tests towards your 8.0 instance. And when you feel confident that you want to go through with this migration or this upgrade from 5.7 to 8.0, then you just point your application to start working with your 8.0 database, and your upgrade is done. So this is upgrading with really like a low amount of downtime. You can also use replication for scaling out read operations. So let's say you have your production application, reading and writing data to your database on the left side. And then you have some back office applications, BI analytics, or a backup server. And then you can set up replication and run those jobs on the backup server, on the replica, which will kind of increase capacity on your read-write production. So here you have dedicated applications sitting on the replica. It could also be that you have an advanced application. So you're running multiple instances of your application, and you can send the write operations and some reads to the primary or the source. And then the application is also capable of connecting to the replicas, to sending read requests to the replicas. So this can really like scale read operations a lot. And most applications today, they're reading much more than they're writing. So these are some of the use cases for using replication. So let's look at architecture. What do we want to achieve today? So today we will set up two MySQL databases in Frankfurt in two different VCNs, so two different virtual cloud networks. VCN1 will have the network mask 10.4, and VCN2 will have the network mask 10.3. And then we will set up replication in between those two databases. To be able to set up replication, the two VCNs needs to be connected. For that, we will use a local peering gateway and set up peering in between these two networks, which means that they can actually connect to each other. So this will be the setup we will be targeting today. So let's look at the plan for getting this setup up and running. So first, you will need to set up two networks. I'm calling my networks VCN1 and then VCN2. So you will create your network, you will create the local peering gateway, and also you need to update your security list to allow MySQL traffic. So this is quite straightforward. So creating the network, that's the first step. Network setup is really easy. I will do everything in the Frankfurt in the Frankfurt data center, the Frankfurt region. So setting up a network, it's really simple. You're using either the wizard or you just create a VCN. And then you're just filling out the sections that's needed. The most important one, of course, is your CIDR block. So what should be the net mask or the CIDR for this network? In our case, VCN1 will have the CIDR block 10.3.0.0/16. And then it actually suggests to create these other network, these sub-networks, and just allow it to do that automatically for you. So all you need to do is fill in the name, the CIDR block, and everything else will be taken care for you. So it's really easy to create a network. The next step is creating the local peering gateway. It is as easy. I will show you this, how to create the local peering gateway. So this one, the local peering gateway, that's needed to be able to communicate in between two different virtual cloud networks. So that's the functionality of the local peering gateway. And the local peering gateway, you will find it under your virtual cloud network. So under Virtual Cloud Networks, you can select your VCN, VCN1, and then under Resources, you will select Local Peer Gateways, and then just press Create and just assign it a name. That's it. It's that simple. So I will show you how to do this, jumping a little bit in between these things. So under, as I said, under networking, you have Virtual Cloud Networks, and you can go and create your network. It's super simple. You just provide your CIDR block here. So this will be for VCN1, it's 10.3.0.0/16. That's all you need to do. After that, you can just create your VCN. It will create the subnets and everything for you. So this is really simple for creating a network. And then you just press create VCN. As you can see, I've already created two VCNs. VCN1, which is the 10.3.0.0/16, and then you have VCN2, which is the 10.4 network. If you then want to create a local peering gateway, you just press your VCN. I can press either of these, VCN2, and under resources, as I highlighted, you have local peering gateways. So just press the local peering gateways, and then you can press create local peering gateway, and you just assign it a name. And you can call this whatever, LPG, I will call this temp, that's it, and just create. And then quickly you will have a local peering gateway. So it's super simple. And this is connected to your virtual cloud network. So after this, we have now created our VCN and we have created our local peering gateway. Then we also need to allow traffic. So we're doing this, the security list, it's like a firewall on the network. So it's kind of deciding what traffic are you allowed to send within inside this VCN. So we need to be able to update the security list to allow traffic to the MySQL database, to the MySQL HeatWave instance. So what we will do, when you go into the virtual cloud networks, under network, virtual cloud networks, and then you select VCN1 and VCN2 for VCN2, and then we need to allow traffic to ports 3306 and 33060. So classic MySQL traffic and also MySQL X protocol traffic. And this is really simple. I will show you how to do that. You just add an ingress rule to your existing security list, and you provide the source CIDR, which is, in my case, I set this to 10.0.0.0-8. So I allow anyone from the 10.0 network to connect to these ports, which is the ports of 3306 and 33060. So all connections to MySQL is allowed on the 10.0 network. So that's the security list update. And I can show you this one. So if we go to the virtual cloud network again, here, you press your VCN. I can take VCN2, and then you go into your subnet, and you go to the default security list. You will see the security list for this one. As you can see, I've already added this rule, but you're doing this, add rule, source, and you're specifying the source. In my case, I added 10.0.0.0/8, and then protocol is TCP, and then destination port is 330.330.6, which is MySQL, and then comma and 330.60. And then you can enter a description like MySQL port, MySQL traffic, and you create this one. Once you hit add ingress rules, you will see two rules, one for 330.6 and one for 330.60. So this is really simple. So now we allow traffic to MySQL within inside our VCN, and you're doing this on both of your networks. So really straightforward. So update the security list. So we're allowing traffic to our MySQL databases that we will set up later on. And then we will do exactly the same thing for VCN2. So I will not cover this. I will go through it really quickly, but you will have this in the instructions. So if you've done VCN1, you will realize that VCN2 is exactly the same. The only difference is, we have a different CIDR block. So we're using the 10.4 for VCN2, and we have 10.3 for VCN1, because we cannot have overlapping CIDR blocks if you want to communicate and route traffic in between them. So they need to have different CIDR blocks, but that's of course the way networking works. So you will do the same here, creating a network for VCN2, and you will add a local peering gateway also for VCN2, and you will update the security list for VCN2. So pretty much the same things that we had for VCN1. So after we have created both of our networks, we added a local peering gateway, and we have now updated the security list so we allow traffic to MySQL. We now need to establish a connection in between our two VCNs. So we need to establish this peering connection in between VCN and VCN2. So what we will do, and this is just visualizing it. So you have VCN1, which is the 10.3 network, and VCN2, which is the 10.4 network. And now we want to set up peering. So we want to connect the two networks via the LPGs. So the LPGs that we created, they're just sitting there, but they're not paired, they're not connected to anything. So in this step, we will actually connect the two VCNs. So communication, traffic can flow in between the two networks. So VCN peering will connect two networks in the same region. If you have two different regions, let's say you want to set up a connectivity in between two virtual cloud networks sitting in two different regions, for example, in Frankfurt and Amsterdam or Frankfurt and Stockholm, then you need to use dynamic routing gateways also for sending traffic in between regions. But that will be covered in a subsequent, in an upcoming webinar on how to do that. So today we will look at setting up VCN peering within inside the same region. And this will of course allow you to send traffic between your resources in the different VCNs. So if you want to be able to communicate set up replication for MySQL, or if you want to be able to connect your different computes running your applications in between the VCNs, you need to set up this VCN peering. But you also need to set up and update your routing. So you're allowing routing to route traffic in between the VCNs. Without peering, you could also do this, but then you need to kind of send the traffic via the internet gateway, which means that your traffic will go via the public internet. And that's, of course, it will add latency, it will be slower, and of course, it's insecure. So if you want to communicate in between different VCNs in Oracle Cloud, we highly recommend using VCN peering and not sending the traffic via the internet gateway. You also have a reference here to our manual regarding the local peering gateway. So establishing a connection between our virtual cloud network 1 and 2, it's really simple. So you can decide if you want to establish this from VCN1 or VCN2. So you go to networking, virtual cloud networks, and you pick VCN2, for example. Then under resources, you will select local peering gateway. So this is the gateway we created earlier. On the right side of the gateway, you will see that there's some action, 3 dots, action menu. And then you just select establish peering connection. So this will establish the connection in between the two different local peering gateways. The only thing you need to do then, you need to specify which virtual cloud network do you want to connect to. In this case, since we're doing this from VCN2, we want to connect to the VCN1, and then you're specifying the gateway, and there will only be one, the LPG VCN1, because we only created one. And then you just press establish connection. So it's really simple. But I will show you this. So as I said, we will go to one of our VCNs. Let's pick VCN2. And then we will look here on the resources, and you can see local peering gateways. And this is the LPG temp that we created earlier. And we're now in VCN2, so the 10.4 network. And if we go to the action menu here, the 3 dots, and you can see establish peering connection. If you press this one, you need to then choose. So where do you want to establish a connection? So I want to do it, and you will get the list of all of your VCN inside your compartment. And I will do this to VCN1. And then you need to select an unpaired gateway. So a gateway that's not paired. In my case, I've already done this. So it's grayed out. But here we just pick LPG VCN1 and then click Establish Pairing Connection. And then you're done. It's super simple. So I will remove the LPG we created here because we already have an LPG up and running that's actually connected and paired. And this is LPG VCN2, and it's connected to the LPG in the 10.3, so VCN1. So once you've done this, our two networks are paired, so you can actually send traffic in between them. So, but before traffic will actually be able to be sent in between them, we need to update our route tables. Otherwise, we don't know how to send data in between the VCN. That's actually governed by the route tables. So we need to update the route tables both in VCN1 and in VCN2. So this will, of course, kind of make it possible to route traffic in between your two different VCNs. The route tables are there for kind of handling, sending traffic either via a VCN or via the internet gateway or via a dynamic routing gateway. So this is pretty much like your standard on-premise routers, handling kind of how to send traffic in between networks and stuff like that. So we need to update the route table for VCN1. So you go then to networking, virtual cloud networks, and you select VCN1. And then under resources, you select route tables. And then you need to select default route table for VCN1. You will see that. And then click add route table, add route rules. So you want to add a rule. And in this case, we want to add a rule for sending traffic out our local peering gateway. So the target for this rule is sending traffic via our LPG. And then you're specifying which is the destination block, the CIDR destination block. And in our case, since we are in VC1, VC1 had a 10.3 network. So if you're going via the local peering gateway, that's connected to VCN2. So any traffic that goes to VCN2, which has the CIDR block of 10.4, so traffic to 10.4 will be sent via the local peering gateway that we just now connected to VCN2. And the description, you can add traffic to VCN2. So any traffic, as you can see on the right side, once this is created, you will see that all traffic is by default going to the internet gateway. But traffic to 10.4, any traffic to 10.4 will be sent via the local peering gateway, which is connected to VCN2. It's called LPG VCNN because it's sitting there, but you know that we actually just now established a connection to VCN2. So that's how easy it is to update the route tables. And then you will do the same update to the route tables in VCN2 if you want to send traffic also in the other direction. So then you go to VCN2 and you select add route rules to that to the route table of VCN2. And then you say any traffic to the 10.3 network will be sent via the local peering gateway. And then you can add a description. So after this, we're actually sending traffic in between the two different networks. And I will show you how to do this also in our manual here. So if we go to the virtual cloud networks, we select under resources, you will see route tables. And here you can see the default route table for VCN2. If you press this one, you will see that normally it only has one, this internet gateway, if it is a public network. And then you can simply press add route rules. You're specifying dynamic local peering gateway, and then you specify the destination CIDR blocks. In our case, since we are in VCN2, this will be 10.3.0.0.0, which is the subnet of VCN1. So this, like any traffic that's supposed to go to 10.3, send it via the local peering gateway. And then you can just select here a target local peering gateway for this traffic, and this is our local one. That's it, and then you press add route rules. And I've already done this here. As you can see, any traffic with this destination will be sent via the local peering gateway, which is connected to VCN1. I'm now in VCN2. So it's really simple. And then of course, you will do the same thing, exactly the same thing for VCN1. So under VCN1, you have route tables. You have your default route table, and then you can add routing rules. And this will be then again local peering gateway. Here it will be 10.400-16, and it will be the local peering gateway. And you can add a description and add route rules. So it's super simple. So we're now allowing traffic to flow in between our networks, or allowing. We're actually setting up routing, so this will be routed for you. So once you have the routing set up, traffic is sent in between the networks. So that's good. Now we need to create our databases, our HeatWave instances. So we will create one HeatWave instance in the first VCN, VCN1, and a database in VCN2. This is really straightforward. You just go into our menu under databases, you click databases MySQL, and you click create MySQL DB system. And then you're providing a name for it, a description, the type. I'm using standalone. It could be high availability or it could be HeatWave. And then you're specifying which VCN. So this is really straightforward. So create one database service in VCN1 and one database service in VCN2. Then it's done. So I will show you really quickly on how to do this. So you go here, you go to databases, DB systems, press that one, create DB system, specify a name for your DB system. Could be standalone, high availability, HeatWave. We will use standalone. Provide a username for this one. It could be admin, for example. Password, network. You create one for VCN1 and one for VCN2, and then just press create. Super simple. So you have one, then as you can see, I have one database in VCN2 and one database in VCN1. Just follow the guide. Connecting to the database, this was covered in the previous section or the previous webinar by Stuart, so I will not cover that. I will use an approach which is called a jump server that Stuart mentioned, which is just a raw compute server where I installed the MySQL client and shell to be able to connect to the database. Connected to the database after this, you can use the MySQL client. And since I'm using a user called admin and a password welcome one exclamation mark, this is how I'm connecting to the database. It's really simple. I will show you that later also. But if you're worried about how this works, how to connect to MySQL HeatWave database, this was covered, and there's a really good 30-minute session by Stuart on how to do that. That was our previous session. So if you want to find the IP address of the MySQL instance, you just go to the MySQL in VCN1, for example. That's on the databases MySQL, and you select the MySQL VCN, and then you will find the private IP address under the section endpoint private IP. So I can show you how that works. So once you've created your database, it will be available here under MySQL database system, and then your specific database. Under endpoints, you have the private IP address here. You can just copy this one. So this is the IP address of your MySQL database once it's created. And then you can simply connect from your jump server using the MySQL client. And then I've created some data, some test data to make this a bit more interesting. So you can always do that. Create a bit test data on one of your servers, on server one. So I logged into my primary or the MySQL in VCN1, and I created some data. And now it's time to set up replication. So replication, the first thing we need to do is decide which one is the source and which one is the replica. On the source server, we need to create a user account. So then you need to log in to the MySQL in VCN1. Once you're logged in to the MySQL and you see the command for connecting to VCN1 from the jump server, you're using these two statements. So create user to create the user, and then you're granting replication slave. So this user will be used for connecting and setting up replication. And you're allowing traffic only from the 10.4 network, so only from the VCN2 network. So after this, we've created a replication user. That's the first step. The next step is to actually send some data, so provision some data from VCN1 to VCN2. Let's say you have some data. So you will then again connect to VCN, the MySQL running in VCN1, and you will dump that data using MySQL shell. So in this case, we're running MySQL shell. We're connecting to the MySQL in VCN1, and then we run dump instance to actually do a logical dump of all the data. Then we're connecting to the private IP of MySQL VCN2, and then we're loading that data. So after this, we actually have the data from MySQL and VCN1 provisioned to MySQL and VCN2. After we've provisioned data, we need to create the replication channel. So for this, we go to MySQL and VCN2, which will be the replica. And then we select MySQL VCN2. Under resources, we select channels, and then we click create channel. And then you can specify a name, you specify description, you specify the host of the source, which will be the IP address of MySQL in VCN1. In my case, it's 10.3.0.250. You're specifying a port and a user and a password to connect. After that, you just create the channel, and then replication will start working. So it's really easy. After that, you can actually log into the replica and just verify that your setup looks good. So after that, you're done. You have your replication topology up and running in between two different VCNs in Oracle Cloud. So I will show you quickly how this works with the replication setup. So now we are in VCN1. I will go instead to the MySQL in VCN2. Under resources, you have channels. Under channels, you can do create channel. You can specify here a name for the channel. You specify the host. This will be MySQL VCN1. Port, username. This is your replication username. And then you can see that this is already targeted for the MySQL and VCN2. And then you press create channel. Super simple. After this, you will see that you have done replication active up and running. And what does this mean? So I will now connect and show you. So here we have our MySQL replica in VCN2. Here I'm connected to the MySQL primary in VCN1. So if we connect to this one, and I will connect to the replica also. And I've created these test databases here. So you can see the data here. We have 10 rows. Let's say we were to insert an 11th row, but we can look at the replica now, what we have on the replica side. We have 10 rows. Let's insert one more row. We now have 11 rows here, and also the timestamp for the last insert. If we select here now, you can see this was also updated. So the replica is getting information. We can also confirm the replica status by running show replica status. You can see that replication is up and running, and this is connected. This is MySQL VCN2 that's connected to MySQL sitting in VCN1. So replication is up and running. So it's really straightforward to get a disaster recovery or set up a replication in between two different VCNs. Some things to note, I will leave this in the slides. You can see that it might be important to increase the binary log expire log seconds. It's a bit low by default, only 1 hour. Otherwise, everything is like, it's really easy to set up replication, but be aware of that we are removing binary logs quite aggressively on the source. So you might want to increase the bin log expire seconds. Of course, if you want to have a test drive, the MySQL HeatWave, the MySQL database service available today. We're always providing $300 of credit for getting started, for doing a trial. You can go to the web link here to get that. And of course, feel free to connect with us. And also, be prepared. This will also be in the slide deck. I will add this to the slide deck. So be sure that you sign up for our next session, 6th of May, 10 a.m. And here we will cover how to input data from on-premise or object storage to the MySQL HeatWave database. So make sure that you're registering for our next session that's coming up on the 6th of May. So thank you very much for today.